Okay, I think we have everyone that is on time, so we should start the seminar. Welcome and good afternoon to each and every one of you. Thank you very much for joining this now second session of the Urban Models Seminar. I'm Clémentine, and with my colleagues Ali and Ruta, that you can see with the camera from TU Delft. We're very happy to see you again, if it's the second time, or to see you for the first time, to discuss classical analytical urban models and their circulation. So once a month, an expert of urban studies and modeling dissect one model with a general question in mind. This question is, what are the unforeseen consequences of urban model simplification on our understanding of cities? So you can see the program here on the slides. Because indeed, urban models are simplifications of reality, but those simplifications are modeling choices. They're implicit or explicit, but in any case, they have consequences on how we view, how we represent, and how we act on cities. So tracing the discrepancy between model results and empirical analysis back to the model's core assumptions and design is crucial to provide guidance on how to use them, but also to avoid misleading conclusions and ultimately to create better models. So last month, we welcomed Denis Pemin, who presented the unforeseen consequences of central place theories. The recording, if you have missed it, is now available on our YouTube channel, Urban Mod Seminar. So if you've missed it, you can replay it, and Justin's seminar will be online as well. And this month, I'm getting to it, I'm very happy to welcome Justin Delloye. And he answered favorably our invitation to talk about the Alonso model. So Justin works as an urban and regional scientist at Stadbel, the Belgian statistical office. He's also a guest lecturer in economic geography at the Université Catholique de Louvain and a research fellow at the Luxembourg Institute of Socioeconomic Research, LISER. A geographer by training, his thesis on urban morphodynamics was awarded the 2018 PhD dissertation prize of the Regional Science Association International. His research involves integrated quantitative modeling of migration, land use, and transport systems at both urban and regional scales. He's committed to an approach that lies at the crossroads of classical theories of economics, geography, and modern concepts and methods of complex systems. And today, he will be true to this commitment by presenting the Alonso model and its influence on how urban centrality is approached in urban studies and in planning. Indeed, starting with the model's initial purpose, representing a housing market, he will explain how and why this model led to very different applications, conclusions, and interpretations when circulating across disciplines, and more specifically between economics and geography. I'm very pleased to have Justin with us today, and I will hand over to him for a 30, 40, 45 minutes presentation. We will then open the floor for questions. So already during the talk, you can type your questions in the chat at any time. Ruta will be moderating this chat and ask the questions for you at the end of the talk, except if you've mentioned explicitly that you want to intervene yourself, then you can ask your question, but please let us know in the chat. Thank you very much, Justin, for joining us. The floor is yours, and over to you.
Thank you. Thank you, Clémentine. Just give me 1 second to share my slides. Oh. Here we are. Can you see them? Yeah, perfect. Thank you. Thank you, Clémentine, Ruta, and Ali for inviting me. It's my great pleasure to be here and talk about this model I've spent quite a lot of time working on. Thank you also for organizing and setting up this seminar series, which I think is really original and really interesting. Thanks, finally, to all the people who are here. I've tried to prepare a nice presentation and a lot of ideas to share with you today, so I hope you're gonna like it. As Clémentine said before, I'm going to talk about the Alonso model and its relationship with how the notion of urban centrality has been spread towards application in regional science, urban science, and planning as well. But as a first step, and before digging into the model, I'd like first to discuss a little bit this notion of centrality, because I have the feeling that this is a concept we know so well that we sometimes forgot how complex it can be. And I'd like to set up the frame here before going any further. So what do we mean by centrality? Well, when I think about centrality, the first idea that comes to my mind is the very simple and geometric idea that I was taught at school when I was a young boy. So it's the idea of having a geometric center, which we also call the centroid in geography. Of course, for simple geometric shapes, it's very intuitive and easy to find the center. For more complex geometric shapes, we have algorithm in GIS, for example. So this is a first notion, very geometrical, and I think it's the most simple one. But there is another important notion of centrality that I think we are very used to through our everyday life, is the notion of center of mass. So by our interaction with objects in our everyday life, we are used to this equilibrium. If I take, for example, my fill of water, I know that I should not drop it too much, otherwise I will have water everywhere on the table. And I've placed this small eagle toys that you may had when you was younger. At least I had one when I was younger, and it's a fun toy when you're a kid because you don't really understand. But actually, the mass of the toy is concentrated on the extremities of the wings, and that's why you can make it and keep it stable at the extremity of your fingers. So in that second notion of centrality, you do not only consider the geometric shape of the object, like the geometric shape of the eagle toy in that case, but you also consider the repartition of the mass, or, and I will come back to it, any kind of variable within these geometrical shapes, okay? So in geography, we play with those two notions of centrality. I emphasize the geography here, and maybe it's something I must precise right now before going any further. I'm a geographer by training, as Clémentine says, so it may introduce some biases in the way I'm going to present the Alonso model, which on the other end, and I'm going to try to convince you about that, is really an economic model, but useful to geographers as well. So back to the main point. In geography, we also use this notion of centrality. Of course, through the cartographic representation, two-dimensional cartographic representation of objects, we can define centroids, okay? With modern GIS, just need to click one button and you get it. So here on the left of the slide, you have a map of Belgium and the centroid of the country, which is around the municipality of Wallin, where people are very proud to be the geographic center of Belgium. They have some advertisement at the entrance of the municipality. It's quite fun. Anyway, you can also add a variable of interest. For example, here I choose the population density and represent it on the map. Then if you compute the center of mass using this particular variable of interest, the population density, you end up with another centrality for Belgium, the red dot in this case, which is obviously closer to the head city of Brussels, which is the most populated one in Belgium. So we have those two notions. Now, what is urban centrality? Well, I guess there are many definitions of urban centrality, but one that is general enough for the purpose of this talk is that in urban centers, you have the co-occurrence of many special processes. If you want to put it in other words, many maps of Belgium would look exactly like this one. Many variables of interest are spatially correlated with the population density. So when we want to discuss about urban centers, we are actually talking about a complex process and a multi-dimensional process. So the next map, this one on the left of the slide, is a classification of urban centers in Belgium. Okay, it's the result of an academic work from Van Eyck and colleagues, but it represents quite well the way people from Belgium represent their country. And I just take it as an example of three things that I'd like to emphasize about urban centers. The first one is that you have a gradient of the urban intensity, if I may call it like that. What I mean by gradient is that whatever the size of the urban centers that you are looking at, You can always distinguish the agglomeration, so the dark colors on the map, the suburbs, and then the periphery. So on the maps, you have this gradient of color to shade it. Okay, so it's a first important distinction with the two notions of centrality that I've shown before. We do not always want, as geographers, planners, urban or regional scientists, to reduce the notion of centrality to a single point. So that we would like to have something a little bit more subtle. The second thing, which is very important, is that you have also some kind of hierarchy. Here it's a matter of scale. You can either choose to zoom in on the on some part of Belgium until you have only one urban center, according to the definition here, or you can consider a hierarchy of urban centers, and then just as with the centrality notions we have in statistics, if you have more spatial variations, then you must be careful with what you call the center, right? And the last point is actually was actually my first point, is that when you define urban centers, you are dealing with a multidimensional process. Here I've listed a few variables that have been used by those authors to identify urban centers in Belgium. And you have the population density, of course, but also housing characteristic, the build-up patterns, the commuting patterns, and the residential migration patterns. Now, what is important is that all those criteria, we usually split them into two different classes, the morphological attributes and the functional attributes. Okay, so in this case, morphological attributes are the first one, and they are actually describing the intensity and spatial distribution of attributes of interest. Whilst on the other end, the functional attributes relate to the intensity, origin, and destination of spatial exchanges, spatial flows. It's really the spatial interaction perspective, okay? And it's very important to understand urban centers to always keep those two aspects of urban centrality in mind, okay? And it's going to be very important in what I will present you as being what I think to be the most important contribution of the Alonso model. Okay, so now let's dig into the genesis of the Alonso model of monocentric city, and really this genesis is the historical formalization of urban centrality. It all starts with the agricultural model of von Thunen. So it may be counterintuitive or surprising that the story of the urban model of Alonso starts with an agricultural model, but you will see in a minute why it's so important. So it's a model of equilibrium pattern of agricultural land uses that was published a long time ago in 1826. Okay, so we are even before the 1 century before the central place theory Denise talked about last month. This work is often recognized as being a pioneering work in the analytic formalization of space and of the equilibrium land use patterns. Okay, and as such, it's often cited as a seminal work, to say it like that, of location theory and spatial economics. I must say, however, that if you talk about von Thunen to an economist, he may know the guy even without referring to the spatial aspect of his work. Here is what Paul Samuelson wrote about von Thunen work. So Paul Samuelson is a former Nobel Prize in economics. He wrote that von Thunen not only created marginalism and managerial economics, but also elaborated one of the first models of general equilibrium and did so in terms of realistic econometric parameters. So most of the time, as geographers or planners, we are trained that the contribution of von Thunen was to introduce space in modeling and have an abstract representation of space, but actually his contribution is much wider, and it's difficult to say whether he was more an economist or a geographer actually. So the model, I will come back to it very quickly, is just about finding an optimal spatial allocation of land around a given market center, okay? And what you end up in this model is that you have an equilibrium. At the equilibrium, sorry, you have concentrate rings with different land uses, and which land use is where depends on the sell price of the agricultural good and on the transport costs. After this first model of von Thunen, there are two other works that have been very important in the birth of location theory and who also propose slightly different notion of centrality and early formalism. The second work is Weber industrial location model. In this model, you don't only have one market center, still denoted by the letter M, but you also have two supply centers if you want. And the problem Weber was studying was where to locate a firm such as to minimize the total transport costs. So for the goods that need to come from the supply and for the final good that need to be transported to the market. So there are general notions like the notion of isoteams and isodepends that have been introduced by Weber and who can be understood as refined versions of the notion of centrality initiated by von Thunen. And the third series of work, well, I won't detail them because Denis Pumin has presented them extensively last month, is all the works related to central place theory. So in this theory, you have several problems that have been studied, but in a nutshell, the question was always to find a spatial distribution of market centers in an abstract plane that either minimize the number of those centers, minimize the length of the road network, or create administrative districts of equal sizes. Okay, and then as Denis explained, you have different kind of patterns that may emerge, right? But if you are interested in this, well, I invite you to go and look at the videos that Clémentine mentioned just before. Okay, so those three series of work were are actually recognized as the founding works of location theory. Then location theory evolved, and years later, we had the creation of regional science. Regional science is a really interdisciplinary perspective on the same research question as location theory. That's why I usually link them together. So it's an institution now, the Regional Science Association International, who was founded by Walter Eisert. And the first department of regional science was funded by him at the University of Pennsylvania. Okay, so I just pasted for you a formal description of what regional science here is just here on the right of the slide. But why I am presenting you this is because actually the first student, doctoral student, I mean, who graduated from this new department of regional science was William Alonso. Okay, which brings me to the most important guy for this presentation. Okay, so the monocentric city model that I'm going to present in a few moments now is actually presented in his book called Location and Land Use and published in 1964. The book is almost directly derived from his PhD dissertation. Okay, and it's often recognized as the first scientific work on the modern urban land use theory, and by extension, also the first model of urban economics. Now, we started with the model of von Thunen, and I hope that you have understood why there is a link between all those different notions until the Alonso model in 1964. However, don't believe that the link is purely historical. There is a very strong analytical link between the very old model of von Thunen and the model of Alonso. Actually, Fujita, who is another famous urban economist, explained that better than I, and wrote about the Alonso model that modern urban land use theory, which forms the core of urban economics, is essentially a revival of von Thunen's theory of agricultural land use. Okay, so if you know the model of von Thunen, but don't know very well the basics of urban economics, well, don't be afraid, it's exactly the same, but in an urban context. Okay, so that's it for my historical introduction. And I suggest that now we go and have a look at the details of the model. small water break for me. Okay, so let's have a look at this, the monocentric city model. Of course, it's an abstract model, okay, in the tradition of neoclassical economics. So the way I'm going to present it is that I'm going to explain all the different assumptions and the problem that has to be solved. Then I will skip the boring mathematics and I will focus on the result of the model by showing graphics, okay? But first, let's have a look at the assumption because it's essential as a theoretical model to understand all the assumptions because a theoretical model does nothing more than demonstrating a relationship between the assumption and the results. If you don't understand or don't have the assumptions, the theoretical model is totally useless. So I'm going to insist on that, but they are very easy. The first three assumptions of the model are actually almost a copy-paste of what von Thunen did in the agricultural context. And sometimes those three assumptions are called together the isolated urban state set of assumptions. So first, land is a featureless plain dedicated only to housing. Second assumptions, jobs are concentrated in a single point called the CBD, okay, for convenience. And third assumption, the road network is dense, radial, and free of congestion. Okay, what does it mean? When you have those three assumptions, the study of your of all the spatial attributes of your model can be reduced to the study of the distance r from any point to the CBD. Okay, this is why we made those three assumptions, to reduce the problem to a one-dimensional problem. Because of course, today with computer, we can more easily deal with problems of higher dimensionalities, but at that time, and for the sake of theoretical modeling, it's best to keep it simple, okay? And those three assumptions, they are just there for us to express everything in terms of the distance r from any point to the city center. Now, land is dedicating to housing, so it's going to be a housing market. And actually, if I must be totally honest, in the Alonso model, you do not have development of land into housing unit. It's something that had been added to the model afterwards. I will come back to it. But in the original version of the model, it's not the case. So in a sense, the housing market and the land market are the same in this model. Okay, so don't be confused by this. I will keep on talking about housing because it's the traditional understanding of the model. So there is a housing market. We need landowners, right? So fourth assumption is that the absentee landowners, which is also a traditional name for this set of assumptions, first, they spend the housing rents out of the system. Okay, most likely to a place where they don't have to pay taxes. Fifth assumption, they may receive a default agricultural land rent. In this model, we are not very interested in the agricultural land uses, but we need a default land use, like a reference point to compare what's happening in the city and what's happening outside of the city. Sixth assumption, the absentee landowners rent the land plot to the highest bidder. Okay, so it's different from a traditional market. The price is not given, but people need to bid, okay, and the highest bidder get the land plot or the housing dwelling, okay? Those are the three assumptions about the landowners. That's for the supply side. Now let's get to the demand side. I'll talk about the households in the city. So we assume identical reference households. They all work at the CBD and they all earn the same wage, which is denoted Y. They consume only two things, lands or housing space, denoted S, and all the other goods are included in a composite good, composite commodity, which is written Z, okay? And in the model, both S and Z, both the housing space consumption and composite commodity consumptions, they are allowed to change in space, so to change depending on the distance R from the living place to the CBD. Ninth assumption, the households incur a commuting cost T and a housing rent R. Okay, so those are the two only costs they have. Of course, they must also pay for the composite commodity, but for facility, most of the time we assume the price of this commodity is just one. Okay. So the problem of the households, what is it? Well, with all this information, we assume an additional and 10th assumptions that the households are rational, so that their choice can be represented by the maximization of a utility function. Okay, I insist, we do not mean that the households necessarily maximize. I mean, the way they choose, they don't necessarily solve a maximization problem, but we simply assume that this choice can be represented by the maximization of a utility function. So here is the problem. I maximize a utility that depends on Z and S under a constraint. Well, which constraint? The budgetary constraint. I cannot spend more than what I have. So what I have is Y, okay, the wage. And the expenses are the rent multiplied by the area of the housing units, the transport cost, and the expense in composite community. That's a problem of the households. Now, as promised, I'm not going to solve this model using algebra and equations, but I'd like to share with you the intuition of the results. First things I want to mention before going any further is that naturally the city has a boundary, okay? Because there is a transfer cost that's positive, okay? It cannot be null. And the wage is also finite, okay? There is no crazy infinite wage. So naturally, there is a limit, and outside of this limit, it's too expensive for the people to come to the CBD to work. Okay, so just by the assumptions, we have, of course, only one center, the CBD, but we also have a natural boundary in the model. Okay, now before solving the problem of the households, I also need to specify equilibrium conditions, okay? Because we will see in a minute, when you solve the problem, you make it in two steps. First, you are interested in the optimal consumption choice of households for a given living place. And then in a second step, with this information, you compute what is going to be the distribution of all the households in the city. And for this second step, I need equilibrium conditions. And they are very simple and intuitive. The first one, which is the 11th assumption, is that all the households, for example, let's say they are N households, they are all living in the city, okay? There is no homelessness in this model. The 12th assumption is that at the urban fringe, okay, and I've explained why there is an urban fringe naturally in this model, the land rent or the housing rent is equal to the agricultural land rent, okay? It's because it's a continuous model, so we cannot have abrupt changes in the rent. If we had a model in discrete space with clearly defined land plots, like working on a raster file or any kind of shapefiles, municipalities or stuff like that, then of course we could have variations in housing price, but not here because it's totally continuous. And finally, the 13th and most important equilibrium condition is the condition of location equilibrium, which is that the utility of households must be the same and equal to U across all the city, such that no household has any incentive to move, okay? Otherwise, they will follow the incentive because there is no cost to migration in this model, and then it will not be an equilibrium configuration of the city. So that's it for all the assumptions of the model. Just for your information, there are various ways to solve this model, okay? And some can be can provide you with more information about what's really happening in the model. But if you are interested in the details, you may, for example, have a look at the book of Fujita. It was published in 1989, which is really great in explaining the different way of solving this model. And in general, you have two different kinds of equilibrium that you can compute. The first one is called the closed city. The other one is called the open city. In the closed city case, the name is pretty self-explanatory, I would say. You fix the population. So you say, and people must live in this city, and you compute the equilibrium utility values. In the open city case, it's the other way around. You assume that there is an equilibrium utility values, which is most of the time interpreted as the equilibrium outside of the city. And then you find how many people will agree to or will want to come to live in the city that you are modeling. Okay. So now let's have a look at the result. As I said, I will be first a result about the consumption choice of households, and then there will be another result about the equilibrium structure of the city. So the utility maximization that I've shown just before can be represented graphically. And I think that it's enough to get the intuition of the model. So for those of you who had lectures in microeconomics, you know that when you have such problem with two kinds of goods like we have here, well, the utility can be seen as a three-dimensional landscape. And just as with topographic maps, instead of representing three-dimensional functions, we use iso-level curves, which in this case correspond to indifference curves, because my blue curves, by representing the set of points where the utility is the same, well, necessarily if utility is the same, people are indifferent, okay, between choosing one or the other. So I have this three-dimensional landscape, and I have my budget constraint, which can be depicted or imagined as a wall in this three-dimensional landscape. Okay, and the goal of the households is to maximize the utility by remaining, still remaining on the left part of this budget constraint. Okay, and the geometric condition of optimality is that the households which choose the consumption pattern such that the budget line is tangent to an indifference curve. Okay, there are some conditions that enables you to be sure that there is only one of such points. Here, trust me with the little plot. Okay, so let's assume that this is the choice of a household, the consumption choice of a household located at the city center. Okay, now I would like to see what is the difference with an household located further away. Well, for the households located further away, the commuting cost will be higher. Okay, so the disposable income will be lower. For example, somewhere here at the green line, the dashed green line. So in a traditional economic model, well, prices are fixed. The budget constraint is lower. The utility achieved by this household will be lower. But in this model, it's not the case. What? One price is not fixed. The price of the houses, of the land. This price is set by the bidding process. And further away from the city, as they have a lower disposable income, the ability to bid of the households will be smaller. So this will tilt the budget constraint of the households living further away from the city center until this reach not the dashed green line, but the continuous green line. And you see that there, the utility reached by the households living further away from the city center is exactly the same as the utility of the households living close to the city center. So what has changed is the consumption pattern. You see that living further away, households which consume more land, they will have larger housing units, but on the other hand, they will consume less of all the other commodities. Okay, and that's the result of the model with respect to the consumption choice of households. There is a substitution between the two goods, the further away you are from the city center, because the lower your disposable income is. And that's the conclusion nicely formulated by Bruckner, yet another famous urban economist, which is simply that commuting cost differences within an urban area must be balanced by differences in the price of living space. And this, in a second step, induce a substitution effect. Now, if I generalize this to all the households and compute using my equilibrium condition, what is the total equilibrium urban structure, well, I will have that starting from the CBD and going further away, rents. So first, what we know, the consumption of composite commodity is going to decrease, whilst on the other end, the consumption of the housing good is going to increase. And rents, which are expressed per areal unit, for example, rent per square meter, they are going to decrease until they reach the value of the agricultural land rent, and this sets the end of the city. Okay, because further away, it's more benefits for the absentee landowners to rent their land to the agricultural farmers. Okay. Yet in this model, there is only housing, right? So if the size of housing units is smaller close to the city center, it means that over there, the population density will be higher, right? In this model, as there is no other land uses, population density is simply 1 over the housing unit size, because all the households are identical. They all have the same number of people living in there, right? And this is why this model has got the interest of geographers as well, because it's a model that explains the decrease of population density further away from urban centers. Another point that's very important is that you're also able to discuss what are the determinants of the urban fringe. And for example, the model shows that the lower the commuting costs are, the further away the urban fringe will be, which has providing an interesting background to support many discussions about urban sprawl in the 70s following this model. One last point I want to make, and that will echo to my introduction, is that sometimes, and sometimes students ask me that, wait, it's called the monocentric city model, so it's supposed to explain what a monocentric city is, but actually the monocentricity is in the assumption of the model, right? So the answer is that you must be careful not confusing the morphological centrality and the functional centrality. In this model, the functional centrality is assumed. We assume that everyone must go to the city center. But the morphological centrality, the fact that the population density will decrease further away from city centers, this one is a result of the model. It's not assumed, it's derived, okay? So again, and now you understand why I spent some time introducing the different notion of centrality. If you want to understand the real added value of this model, it's really about that, making an explicit relationship between functional centrality and morphological centrality using traditional economic assumption, and in particular, an explicit model of the housing market. That's, according to me, the probably the most important contribution of the model, although I'm really open to discuss it with you. Okay, we see I have a few minutes left to discuss the impacts of the model. I will start by the academic impact, because it's always easier, especially for theoretical models. And then I will end by discussing the non-academic impact, or impact in applied research as well. So the academic legacy, well, the book of Alonso, where he published this model, has remained an amazing reference in regional science in general. Okay, I've checked a few days before this seminar. I think there were almost 10,500 citations on Google Scholar, and not only all citations, right, but more than 800 citations only since 2020. So it has been and remain a very important contribution in regional science. In a small survey among members of the regional science community that Waldorf made in 2004, it was the second most cited path-breaking book as well. So it's really important. And as I mentioned, as it is regarded as the founding work of one of the founding work of urban economics, you can somehow say that the entire discipline of urban economics is the legacy of the Alonso model. So of course, I'm not going to list right now all the contributions that have been made. I've just selected a few important extensions that have been made after the publication of the original model, and which have generated distinct research paths. So the first extension by Beckman, quite soon after the model, 1968, was to justify the existence of the urban center in this model by social interaction. Okay, because as I said, the fact that there is an assumption of functional functional centrality was criticized by people who were interested in what this model could provide to explain the centrality and decrease of population density centers. And the first explanation provided by Beckman was simply to assume that people have some interest to meet each other, whether it may be to work or for other things. And he has started a very important set of literature after that on how agglomeration economies justify the existence of the centers that Alonso had previously assumed. A second very important extension is the work of Muth, who has published a book in 1969, where he discussed many aspects of the Alonso model. But the two most important things that are recalled from the work of Muth is first to introduce income effect in the model. So what happens when you have two types of households with two different income levels, and under which condition you have rich household in the center, and under which condition you have the opposite. Okay, so it's very interesting to discuss what we traditionally call American model of city and European model of cities. And the second important add-on made by Mutz, if I may say, is the explicit housing market, which was also something missing in the original work of Alonso. The third contribution is the one made by Mills. And actually, this third contribution is also, like the one by Muth, a book with many different aspects, where many different aspects of the model are discussed. But the one that we recall from Mills are especially the explicit model of traffic congestion, which was again in the 70s an important support for the early discussions of urban sprawl, and also the discussion of urban decentralization. The contribution of Muth and Mills are so important and so complementary to the model of Alonso that most of the time, the monocentric model of Alonso is also called the Alonso-Muth-Mills model. So don't be surprised if you have their name brought together. A fourth contribution made by Anas was to introduce dynamics in the model. And as an economist, he was interested in the durable housing aspect. So the fact that once we build a building, it is durable in time, and then it may influence the further development of the city. Borukmov, Ockman, and O'Hara have also published something in the vein of the contribution of Beckman about the existence of the centers, but this time it has been formalized by firms interaction and not social interaction. And one last paper that I'd like to mention is the one of Bruckner and colleague, who studied the interaction between the presence of amenities in urban centers and income effects. So again, quite well in the vein of what Muth has started to discuss difference between American and European cities. So those are just six examples that I took, but yeah, urban economics has become such a wide disciplines that there are plenty of contributions that could have also come on that slide. Well, in economics, there are also quite a lot of econometric tests of the Alonso model. And then what we should understand is that the model is not necessarily, the contribution of the model is not necessarily the same from an economic perspective and from a geographical perspective. So in economics, most of the time, there were not that much interested in studying, for example, the shape of the population density profile, which is something I will come back in a minute. But they were more interested to study, for example, the estimating parameters describing the effect of transport costs on urban sprawl or those things like that. I've just mentioned a few papers, okay, because I'm not an econometrician, I'm not an expert in those disciplines, but the general comments that maybe say is that in all those tests, these are very difficult tests, okay, because you have a lot of external factors to control for, okay. It's always the tricky point with econometrics, even more with spatial econometrics. The more abstract the model, the more control you have to make when you carry out an empirical experiment. So, but nevertheless, it has been quite an important literature in urban economics, all those tests, and there are always some interesting insights found in those papers. But be careful and remain critical with the way the authors have controlled for external factors. So it was very focused on urban economics, but what about geography? Well, so the paper has been published, so the book has been published in 1964, and in the 60s, well, in geography and in regional science as well, quantitative methods were criticized. Okay, they had really a boom of quantitative methods in the 50s, and in the 60s, people were a little bit more skeptical about that. So of course, a model so formal as the one of Alonso has a hard time to break through in the geographical sphere, if I may say. But there is one application which I think has really caught the interest of geographers. I already mentioned it. Is the modelization of the density profile. I mean, population density profile. So indeed, in the 50s, there was this famous work of Clark, who modeled exponential population density profiles from cities in Europe and in the United States. And in a sense, the Alonso model was providing a proposal of theoretical support for those decreasing density profiles. After the work of Clark, there has been a lot of studies on empirical studies on those density profile. But one new approach was proposed in 71 by Norbeck, who started to study the allometric properties of those density profiles and of those shapes of cities. So allometric means that Norbeck studied how the shape of the city described by the population density profiles change with the size of the city, okay? That's in a very, very brief definition of what allometric allows may be. And after him, there was, I think, to me, the oldest example I can remember is the study of Berthaud, who studied this allometric relationship, but not only restricting the description of density profiles to aggregated values such as total surface of the city, etc., but taking the entire shape of the profile. And here on the right of the slide, you have this rather famous picture, I think, where you have 7 different cities with very different population, but displayed at the same scale, so that you can really compare the extension of the city and the height, if I may call it like that, being the intensity of the population density within those cities. Okay. And I think the most recent work in that respect is the work of my colleagues and friends, Rémi Lemoy and Geoffrey Caruso, who have also studied the allometry of those density profiles, but using the homothetic scaling of the profiles as a measure of the allometric rules. And I'm going to very briefly show what they have done, because as you will see, the Alonso model may be used even today to learn new things about cities. We just need to take a different perspective on that model. So in one slide, what did my colleagues do? Well, their question was very simple. They wanted to know whether the European density profiles could be similar up to a dilation, of course, a dilation that's proportional to a power of the population. So the question is, can we regard all the density profile as the same, just being dilated or the opposite? Okay, so I just put the equation for those of you who understand it better when it's exposed that way, but that's their question. So they use data, try to find what is the optimal scaling relationship. And what I found is that there is the empirical evidence of an optimal scaling with the power of the population being 1/3. Okay, I will not discuss why this 1/3 is actually intuitive. I just invite you to read their paper for that. But now the point is that after having this empirical result, they wonder, okay, can we provide a theoretical ground for this? And starting from the Alonso model, which was probably the first theoretical model of decreasing population density profile, can the Alonso model provide some explanation to this? Well, the answer is yes. It has not been questioned before because in economics, most of the time, economists do what they call comparative statics. So they compare two results of the model, changing only one parameter. Here, to study scaling, you have to change at the same time all the parameters that are related to the population. So in a work that I had the pleasure to do with them, we simply assume that in our Alonso model, the wage and the commuting cost change with the size of the city. And once we introduce this in the model, we can compute the condition for homothetic scaling and the kind of scaling observed by my colleague Rémi and Geoffrey. And the result infer from the theoretical model is that the scaling should be 1/3. So the Alonso model, although it was not developed at all to study the scaling of cities, can provide relevant information about this scaling. So I just wanted to emphasize this example to show that regarding the academic impact of the model, may it be in economy or in geography, it's important, and it can be even more important if we take enough time to try to bring new perspective on these old results. Now I see I'm running a little bit out of time, but I will close rather quickly with the impact on policy. Why quickly? Because it's harder to discuss, okay? When you have theoretical model like this one, you do not find explicit mention of the Alonso model in documents. In my experience, the impact of this model is quite important because it goes through two different channels. And again, it depends on which are the people bringing this the result of this model to policymakers. And I will use policymaker in a very broad sense. So the economist way I say, if I may say, is twofold. First, you can provide theoretical recommendations to policymakers. So very simple rules, very simple principles that you pass through them through consultancy, workshop, stuff like that. For example, decreasing commuting costs, be careful, it may increase urban sprawl. For academicians, it may look very simple, like too simple, but we tend to underestimate the work that needs to be done to provide the academic information to the apply world and to policymakers. The second way economists works is with empirical estimation. There were quite a lot of econometric estimations provided in commission reports by international or national institutions, especially on urban sprawl, and I can also provide an operational information. Now, the way geographers work is a bit differently, and in my experience, I think the way geographers have brought the knowledge of the Alonso model to policymakers is through predictive models. Okay, indeed, in all the land use and transport infrastructure model, as well as some residential migration model, you can always find even a simplified version of the Alonso model, because it always remains a key element in understanding the evolution of land use in a territory. And in that case, I think it's very interesting because it's a very practical way of passing the information provided by this model. And in recent years, I also see there is more and more application of policymakers at the beginning of the development of the model. I feel like it's a recent trend. I don't know if you would agree with me or not, but I think it's more and more the case, and it's a good thing because policymakers are really more able to understand and use a model if they have been implied in its development. And to finish, I'd like to say that, okay, the Alonso model may not be directly cited in official documents, but the notion of centrality is very important, okay? International or national document, you often find recommendations to reinforce urban centrality related to the desire to have a sustainable regional or urban growth. And the active debate is what compactness is enough and what compactness is too much to preserve other lands. So we may feel like, oh, well, actually the message is passed. I mean, policymakers have understood. But if I take, for example, the example, of course, of the planning documents in Wallonia, so the southern part of Belgium, there are several goals that relate to the notion of centricity or polycentricity, and that provides recommendation with respect to centers. And now the problem is that in 2020, so the year after this document has been published, there was no explicit definition nor perimeter of the central places mentioned in the document provided by the regional government. So this also showed that although the principle may have been understood very well, sometimes the translation in concrete action is actually prevented by very simple and trivial problems like how can we define centrality in a precise way. So I don't want to conclude on this slide like if it's something like a pity, no, but it's just we must understand from this that sometimes the difficulty to pass the information from the academic world to the applied world, if I may say it like that, the difficulty may not be that hard, but it may stand in unexpected places. And this concludes my presentation. It's tiny few minutes late, and I'm open to questions.
It's okay. Thank you very much, Justin. We can virtually clap for this presentation. We have a question already in the chat, but I want to ask you first the same type of question I asked Denise last month. And I think there's a really nice transition as well with her talk, because she mentioned how the diffusion, the circulation of central place theory was made difficult, for example, because of translation problems. So the full book wasn't translated necessarily into English, so some parts were missed. And also coming from geography, it was sometimes lost in between the disciplines. In the case of the Alonso model, it really comes from a dominant discipline, so economics, and a dominant language, so in one of the dominant places also for this kind of research. So in this case, could you say, for example, that the model circulated too well, even in places where it wasn't supposed to be helping necessarily or wasn't adapted? And the second question related to this is, what do you think is the main misunderstanding of the model and its influence on research and policy? And is it linked to, for example, the fact that it comes from models of agricultural production, of industrial location, so not cities per se? Sorry for this long and intricate question.
No problem. Thank you for this interesting question. Well, it's interesting. I wouldn't have said that it has spread too much, but definitely it's still not totally understood, I think, by all the different profile in the community of regional scientists. I don't think it has anything to do with the fact that it originated from agricultural model, because while the legacy from those older models is really related to the way space was formalized. And even in the 60s, I mean, the fact that space was very marginalized in economic studies, it was not by lack of interest, but because it was difficult to integrate it. So on the other hand, I think it's really good that that Alonso was able to find in older models and models that were maybe not immediately and obviously relevant for the study of cities, that he could find in those models what was necessary to make this extra step to our modern land use theory and everything that has after. Well, the most important, what is according to me the trouble in the spreading of the model is really that people do not necessarily understand. When I say people, I focus on geographers because being a geographer myself, I've heard more about debates from geographers. They sometimes forget that this model is very economical, developed by an economist, and that the intuition within is really an economic intuition. So of course, the result is a decreasing population density profile, and it's very interesting for geography. It was at that time, but the key of the model is just a substitution in a consumption pattern. There is nothing. I mean, I think there is nothing more economic than that, and that's why sometimes the model may be also misused. But nevertheless, I wouldn't be too dramatic about that, because as I said, although sometimes people don't realize that they are using this model, it is present in new kind of models, numerical models that geographers are more used to work with, like, for example, land use and transport interaction models I've mentioned. So, so the legacy is there. I think the sense of the message has passed, but we still recall some intense debate because it has appeared at a time in the 60s where economists were remaining, at least within the field of regional science, remaining very quantitative. And on the other hand, geographers were bringing important questions about the limits of quantitative methods. But yeah, I also have the feeling that those kind of hard debates can also bring brilliant new ideas and make a scientific community growth wiser. At least this is something I hope. Did I answer all your question? I think I did, but.
Yeah, there would be so much to say, but yeah, thank you for this answer. I will give the microphone over to Ruta for questions that might appear in the chat. Yeah. You're very welcome to pose your question in the chat.
Yeah,
thank
you, Justin, for this great presentation, and you covered so much in such a short time. And yeah, before a question, I just wanted to say that I agree that this model is very important for geographers. Of course, I'm a geographer also myself, and this model is very spatial in essence. And we had a question in the very beginning of your presentation, so maybe this person is very impatient, so let's give him an answer. In the beginning of your presentation, you showed the slides. Well, you showed the slides all the time, but in the beginning there was a slide about urban centers, about agglomeration, suburbs, periphery, capital, large, regional, local, city, and this person, our listener, is interested who made the research. You show the maps.
Yeah, it's so the original work was made in 2001 by Van Eck and colleagues in Belgium with data from the census. But the map that I've shown there, it's just a copy of their map that I made so that it's nicer on the slide, but exactly a copy of their map. And I think this revised version has been proposed in 2017. Van Eck is not the first author, but I forgot who is the first author. But I can send it by email to the interested persons.
Yeah. Thanks. So maybe we'll hear from Jeep Lessons if he wants more details. And I have another question, a bit maybe uncomfortable or provocating, but it's about all models. I think all kinds of models. Provided us with lots of assumptions of the model. I think 15 or close to that number. So like there must be empty plane, no homeless people, all people work in central business districts, etc. So I was wondering, well, none of these assumptions actually fit the reality. So why should we trust models? And how can we explain reality if their assumptions are really not real?
Yeah, it's of course it's I mean, it's an eternal question. I think that in 100 years we will still be wondering this kind of question. But my answer on my small experience is that it all depends on the purpose of the model. And most of the time, I think that the interdisciplinary conflicts that I've seen are actually due to a lack of understanding in what are the finalities of the model. So all the models are abstraction of realities. Okay, so the fact that they are simplifications should never be a critics. The question is, are the simplifications correct with respect to the goal of the model? And then you have a plenty of different objectives. For example, in applied model that wants to make predictive predictive results like land use and transport numerical models. In those models, if you want to have results with scenarios that you can compare to reality, you have to avoid most of the simplification assumption. And this is what happens, and you end up with big numerical models that require a lot of data and that are hard to understand, but you can understand the results, okay? And it's perfectly fine. But this kind of model is very theoretical. Here, the point is not to be used directly. The point is to really understand one process. I mean, this usually when I teach this model to students, they leave the room and once told me like, I've learned something I already knew, but I still learn it because I never realized it was the case. When I saw it in the model, I say, oh, I understand. And I could all see that since a long time ago, but I could not really understand what was happening. So one way to say that is that those theoretical models, you cannot do any apply research with them alone, but you cannot do any apply research without them neither. This is how I would summarize the distinction between both kinds of models.
Thanks. Maybe while other people ask questions, I have another one that goes a little bit deeper from Ruth's question, and that focuses on the one-dimensional city and the three first core assumptions. So what you mentioned already is that there's a historical path of development that makes this generation of urban economists think we can't work with too many dimensions, we can't solve it numerically, so let's start by reducing the problem to a one-dimensional city. So that's sort of not theoretically grounded, but really part of making your life easier to compute the model. Do you think that if there was the computational power at the time, this is a set of assumptions that would still make the base of the model, the core of the model, or can you see models that are developed nowadays that really don't start with this because it's not a necessity anymore, and that would only go there if it was theoretically needed?
I don't think that the computational power we have today prevents those theoretical models from existing, because there is always the trade-off. Like the more you put in your model, the less or the harder it's going to be to understand it fully. I mean, even in the simple model of complex systems, we can sometimes have very simple model whose assumptions looks really like toys, like games, and the results are impossible to understand because of those nonlinear processes. And actually, in the big numerical models that we use, we face those nonlinearities and high dimensionalities. And so although the results are easier to understand, the model is much harder to understand. And the only way I see we can hope to better understand those models is to split their complexities into small, simple questions. And this is where, in my understanding, theoretical models such as the one of Alonso complement the complex applied numerical model that we are more used to in geography. It's like you need a collection of simple model of the Alonso type, if I may say, to understand deeply the result of one big numerical model. The way I understand this is just inherent to our brain size, if I may say, that we cannot. At some points it's just very difficult to go further into big models and to introduce further variables, etc.
I think it was just too clear during your presentation. So everyone has just exactly the amount of knowledge they wanted from this presentation.
That's great.
But, unless there are other questions, I guess my question, and your answer is definitely very good, but in the hierarchy of assumptions, is the reduction of city to a one-dimensional problem so necessary to be the first set of assumption? Was what I was trying to say. Like, does it need to be the first thing you assume about the city when you try to model its density distribution? But you are on mute. Yeah.
Yeah, but I was thinking, so I was trying to gain some time muting my mic. Well, I'm not sure I understand totally your question, but I don't think it's the most important assumption. There are many other assumptions that are very important. I think people focused on that one first because it's among the most important contribution introducing space into urban economic models. But anyway, I mean, question like the rationality of households, which is a lot discussed even outside of spatial economics. It's more a discussion of what is economics as a whole. It's a set of assumption that is as important, I think. So when I present all the assumptions and why I wanted to present all of them and put a number behind them to be able to discuss them, is that you need to understand all the assumptions, because as soon as one is not correct in your applications, again, thinking that you use this model to understand more complex things, then you must be able to say, oh, but here the assumption is not exactly the same, so maybe I should not trust the Alonso model that much. But I wouldn't go too formal with the assumptions. They are nothing more than assumptions. The model matter, and we need to understand the assumptions. But I wouldn't say there is more or less important assumptions in this model. It's just some came out from history with more interest from the public, from the audience. But that's another matter, I think.
And we have a question. Did you consider the Legendre, I'm not sure if I pronounce it well, Legendre structure of von Thunen? What I Googled, it means like this shape of curve.
Legendre.
Unmute. Please unmute, Justine.
I'm not sure what I mean by Legendre structure of von Thunen. I don't know if the asker maybe clarify a little bit.
Maybe Robin, if you want to ask your question. As a specialist of von Thunen, do we still have Robin with us? So it's not Legendre, it's Legendre, but I guess it's
Legendre.
Yep. Thanks, Robin.
The von Thunen model has a fairly simple Legendre structure, which means you can transform its coordinates. And Roy, the Australian, showed that there's a similar Legendre structure in gravity models, which allows you to model von Thunen on a multipolar scale, polycentric.
Yeah.
And I just wondered whether you'd picked that up at all.
Well, okay. Thanks for the clarification. No, I get the question. I must say I'm not. I don't know all those methods of coordinate transformation very well. At least I've not discussed or studied a lot what it may enable to do with the von Thunen model. But the way I understand your question, I think it's really related to what I was trying to say about the hierarchy and the fact that as the functional centrality is an assumption, in a sense, you may assume multi-centrality or any kind of functional distribution of flows, of commuting flows, and the results of the Alonso model remained totally valid. Okay, it's just another shape in the space. Instead of having one centers, you will have a hierarchy and different subcenters. So and that's yeah, something that maybe sometimes is misunderstood. So I'm not sure whether it's the kind of generalization that the Legendre transformations may enable to do. But if this is that kind of thing, then I do agree that it's totally in the phase of the model.
Well, one of the assumptions, which I don't think you stated completely, but it's probably included within the totality, is that the Alonso model is a model of perfect competition.
Oh, that's right.
That's right. The polycentric model is a model of imperfect competition, which is, I think, much more realistic. I mean, the assumption of homelessness is also, and no homelessness is also a perfect competition assumption. Mm-hmm. But it becomes more interesting when you consider the boundaries, because it's all very well considering a sort of monopolar structure in Kansas somewhere and the agricultural land value surrounding it. But in Europe, most cities are not really surrounded by agricultural land values. They're surrounded by other cities. And it's trying to understand that kind of structure and the dynamics of it that are interesting, I think.
Mm-hmm. Yeah, it's true that so there are two parts. First, it's the interesting question of scale. So at some point, maybe the scale of analysis is not the right scale to use the monocentric city model. And I mean, with that respect, all the literature about fractal cities, but I think there's going to be a seminar about the fractal approach of cities. So I won't spoil the Cécile Tanier here. But this is a discussion about, okay, at some point you shift from one centers to a polycentric structure. Do you consider it as one polycentric cities or a system of independent cities? And it all depends not only on the morphology, but of the flows between. So in a sense, it joins what you mentioned about the fact that cities may be surrounded by other cities, or do you consider they are the same cities, and not a very clear and easy definition like in the Alonso model where you end up in the rural area. And the second point, and I totally agree with you, of course, opening the standard assumption of economics, like removing the perfect market assumption, it's of course it's open a lot of different perspectives on the model, and it's and I think that opening those perspectives, okay, maybe not all at the same times, but one by one, this is the way I think we can build this collection of simple models from which we can understand more complex models. And I do agree that it's a very interesting topic to study, definitely.
Thanks.
Thank you.
Thanks to both of you. I think if there are no more questions, we can stop quizzing you, Justin, because you did a really, really good job at exposing the Alonso model really clearly with the impact on academia and policy. I think it's very clear, and it's going to be very useful in the future when we rework it into a podcast as well. I want to thank you once again, and I want to also let people know about the next seminars coming. So you referred to the one on fractal cities, so that will be for February, the 7th of February, when we receive Cécile Tanier. But before that, We've got the next session coming up in 3 weeks on the 13th of December, where Jessie Le Rousseau will talk about economic-based theory. So once again, we've got a transition from your talk to a very economics geography interface kind of model. So I want to thank once again everyone for attending the seminar, for asking more questions. Thanks to Ruta and Ali, and we're really looking forward to the next session. And in the meantime, thank you, Justin. And,
thanks a lot. It was my pleasure. Thanks to everyone.
Thank you, Justin.